Hello and welcome everyone to No Cabin Fever today. I'm Michaela from Scandio, and with us today is Adam Such from Sonatype, and he will talk about Automate or Die, DevSecOps in the age of software supply chain attacks. I will now hand over to Adam, so please enjoy.
Thank you very much. Yes, let me just share my screen. Yep, hopefully you can see that. Good, perfect. Yeah, so my name's Adam Such. I work at Sonatype, and yeah, today I'm going to talk about automation for DevSecOps in the age of software supply chain attacks. So there's more and more attacks appearing throughout our software, but specifically around open source components. I'm going to talk today. So I can see chat coming in. Hopefully everyone can see everything okay. Yes, so to give a bit of background, Sonatype run Maven Central. So we run the main community for people downloading Java components, and we've seen that grow and grow over time, and it always surprised me every year. I've worked at Sonatype for nearly 3 of these releases now, and every year it goes up and up. There's an exponential increase in people downloading open source components from Maven Central, and it just goes to show the growth of open source usage within software development. People talk about Java being a dying language and people moving away from it. These downloads show, even if that is true, which I doubt it is, there's so much usage, it just keeps going up and up in terms of open source. And we see the same thing happening in JavaScript in the NPM ecosystem. And I'm sure if we had the stats for PyPy, RubyGems, all those different ecosystems, NuGet Gallery, they would all be doing the same thing. We just see open source growing and growing, more and more components on those ecosystems, and more downloads. This is to the point that I go out often to customer sites and actually scan their applications and look at their open source. And we see 80 to 90% of a modern application is open source. So only 10 to 20% is your own code developed in-house. So the kind of usage shows there that it really is big and a big part of your applications. And lots of people have things like static code analysis to look at that 10 to 20%, but kind of ignore this 80 to 90%, which is obviously a big part. But of that open source, lots of it's very good. So, for example, if you're going to do some cryptography in a application, no one is in their right mind is going to go and write that from scratch nowadays in the modern world. You're going to go and download it from an ecosystem, and often they're very good. But some of them aren't so good or have gone bad over time. So you kind of talking about how we can make sure these things stay good, being aware when they go bad, and also things like licensing, which is often harder to kind of define and understand. So you just need to know what you're pulling in. Just pulling in random stuff is going to make it difficult, and you're not going to know when it's gone bad. So to set a bit of context on this, I'm sure we all know about cybercrime, but it often shocks people that it actually overtook drugs in terms of profitability back in 2016. So that often surprises people. And this kind of goes some way to show why the attacks we're seeing are getting more and more sophisticated. So obviously, cybercrime is less risky. It's drug trade is not growing, whereas the cybercrime is. And there's good reason for that. It's hard to prosecute, it's hard to track down, especially if it's cross-border, and sometimes even state-sponsored, as I was going to in a moment. But yeah, one is growing dramatically, the other isn't, and it's no surprise that it's cybercrime that's growing very quickly, and that means there's more and more money and more attacks, and it's kind of getting more targeted. So just put that in a bit of context. That's the kind of scale we're talking about. So just to pick an example, Equifax, which is a credit rating agency in the US, have some presence in Canada and the UK as well. But they handle very sensitive information around credit ratings, things like national insurance numbers and those type things. They were actually attacked through an open source vulnerability. So back in September 2017, they announced a massive amount of their data was actually stolen, and it was a pretty big breach. There's been quite a few breaches like this, but this was just probably one of the biggest and most high profile. And it actually ended up being tracked down, as I said earlier, to state-sponsored kind of actors. So it's actually the Chinese in this case. We've seen North Korea implicated in other attacks, and this kind of goes to show how these attacks are going on, and it kind of really shows that money going up and up all the time, with states are beginning to sponsor these type of things, but also criminal gangs as well are beginning to attack people. So we're seeing this, and I'm sure you've all heard these kind of COVID attacks, people going after kind of banking and things like that with spam type email. But we're seeing the same kind of thing in kind of organized application attacks. So there's a good reason cybercrime's new best friend. So I have lots of people say to me, well, I'm not Equifax. I don't have a lot of valuable information hidden in my application. I am not handling credit card information or anything like that. A lot of people say this to me, but actually it's kind of changed with cryptocurrencies, because actually your CPU has value to an attacker, your visitors as well. So if they can get into your website, they can begin to attack users. And we've seen this with things like torrent sites, but it's becoming more and more prevalent. And your build infrastructure has CPU cycles as well. People don't think about that, but it's often quite big infrastructure that's sat around doing not a lot, quite a lot of the time when you're actually running builds. So they can actually use that just to mine cryptocurrency and directly make money from these type of attacks. So it's kind of an interesting new development on this, to the point where there's been targeted attacks on Jenkins. So people who've left older unpatched versions of Jenkins open to the internet, they've managed to use open source vulnerabilities to go after that build infrastructure and actually use that to mine. And for one specific attack, they tracked down $3.4 million of Bitcoin being mined through this type of attack in Jenkins. So good point to go and update your Jenkins and maybe not make it public, but also, yeah, be aware of these type of attacks going on. Now, I'm not going to go too much into these. We're not too long a session, but just to pick a few of these type targeted attacks, as well as obviously open source can just go bad over time. Well, going back to the Equifax example, that was a particular library they were using that just happened to go bad. But there's targeted attacks, so things like people accidentally publishing their npm credentials and people using them, right through to things like this typo squatting, so PyPy, and actually only very recently Ruby gems as well. So that was kind of this week we heard about Ruby gems. People just kind of using names that look like open source components they'd expect to pull in. And it's very simple attack. So Atlas dash client was the attack, whereas Atlas underscore client is the real one, the real library that people expect to use. And it's very easy for a developer just think, oh, I know Atlas client, I'll just use that, and accidentally put in a dash rather than an underscore. And they pulled in a component that looks like the thing they expect and works in the same way, but actually it is vulnerable and is actually malicious. And we've seen, yeah, this in PyPy. It's happened in npm, it's happened in Ruby gems, all the ecosystems, kind of these dedicated attacks. And most of them have been things that are a bit almost silly, like cryptocurrency attacks. But there's been some more serious ones, like ESLint set up to try and steal your NPM token. So this was a compromised account introduced a new dependency, this ESLint scope, into ESLint, which is very popularly used. And then it went after NPM credentials directly to trying to actually just steal people's account to presumably then do more targeted attacks within the NPM ecosystem. So yeah, so interesting attacks there. But part of the complexity of managing this is that, as well as obviously defining open source that you use, so just saying, I know this interesting library number is not a number, seems like a easy thing just to pull in and use. It's JavaScript library in this case. Pulling in that single dependency yourself will then, within the tooling, pull in a whole load of other transitive dependencies. And this can be a very complex structure. There's obviously hundreds here of dependencies you end up getting just by pulling in that single one, and some of them even kind of with a multiple definitions, so you end up with kind of a complex structure trying to understand what you've pulled in from where and how. So this kind of goes some way to explain the complexity of the problem. And there's the mandatory jokes on Twitter about the NPM ecosystem and how many packages you end up pulling in just by pulling in a few in when you declare them. But as well as kind of the complexity of understanding it, also we need to bear in mind, as those gangs get more and more kind of resource, there's more and more money within cybercrime, the time to respond actually goes down as well. So back in kind of 2006, I think it was IBM did the initial research and said that around 45 days is your time to respond from being made aware of an exploit. So a vulnerability comes in, try and work on it within 45 days. And then Gartner kind of put it at 30 days, about a year later. And then over time, there's been various research kind of put in it at various times. And the most recent one was kind of 15 days. Kind of people generally talk about this now, 15 days within these kind of circles. When I actually speak to most of our customers, when I speak to them, they generally have a policy of around 30 days, 28 to 30 days as a kind of blanket rule for responding to these type things. But actually, with these type of attacks, so the Equifax attack as an example, that was actually only after 3 days. So within 3 days of Apache making a fix to the library, Equifax were actually breached. So the time to respond is getting lower and lower all the time. And with these open source type attacks, we often see within a day or two example code being published on GitHub of how to go and exploit a vulnerability. That's really not uncommon now. So you can imagine if someone probably kind of well-meaning posting on GitHub some example code of how to go and exploit a vulnerability, you can imagine organized kind of criminals are probably quicker than that, these organized hackers. So yeah, you've got to be quick. And that means you've got to be aware of these vulnerabilities very quickly, as well as actually going and fixing them quickly as well. Because yeah, time is of the essence really in these things. So how can we kind of look at this differently and begin to understand our supply chains and what we're bringing in? So back in the 40s and 50s, Edward Deming kind of formed these principles for manufacturing. They kind of define modern manufacturing, and it kind of takes suppliers, ships them into warehouses through to manufacturers, and then produces finished goods. But this maps obviously from traditional supply chains, something like a car, from parts to warehouses to actual factories to actual products. It makes complete sense to map that to what we do. So in terms of suppliers, be that open source components or even third-party software you're buying in, all of it kind of comes in from suppliers then goes through to kind of warehouses like your own internal repositories or those external repositories you're pulling in through to your software developers, your manufacturers, through to your finished web pages, applications, whatever they may be. So you can kind of map it across and then start to apply these principles. And if we kind of think about this, if you look at kind of traditional manufacturing, in this case, I just happened to have picked a car, but looking at this, there's a particular issue here. So there's a particular valve spring that has an issue that could cause problems for users. But looking at this recall notice, you can see that there are specific VIN numbers they're putting it back to. Now, how many people in software development could say they could do the same thing? Say exactly this application contains exactly these components that I'm using. Probably not many of us. I know I certainly couldn't when I was a software developer. So we can start to learn from traditional manufacturing on how they're doing things, how they're tracking everything through. It's obviously not a surprise to us, kind of intuitive. We all know that manufacturers can track all the parts in their supply chain. If a particular wheel or spring or component goes bad, they know exactly which cars they put it into and can track that down and take the appropriate action. We need to start to do the same thing within software. And there are various places we should look. I kind of won't go into too much detail in this, but you kind of need to take various action throughout the development life cycle. So you need to be aware, but make people aware as soon as possible. We see lots of people trying to just block things when they come in, and this is slow. You need an automated process. And also developers kind of get fed up. And if you're approving things and it takes weeks, which is typically what we hear from people who try and do this manually, you're just not going to react quick enough, because as we saw, you've only got a few days to respond to keep up with the hackers. So you need an automated process to vet things coming in, but also just relying on penetration tests right at the end, just before you release. It's kind of a black box. You're likely to miss stuff in terms of open source. And if you do find stuff, it's going to go right back to a developer and probably add a lot of time onto your releases. So it really doesn't fit into kind of DevOps mentality. So you really need automation throughout your software development lifecycle, the development process. But we're also seeing a rising tide of regulation as well. So lots of security kind of regulation appearing, things like PCI and all kinds of different regulation around specifically open source and being aware of vulnerabilities. OWASP was the first one to put it in. So with the A9 back in 2014, out there OWASP top 10. But we're also seeing things like licensing appearing through things like OpenChain, which is set soon to become an ISO standard. So yeah, a whole load of regulation which is aware of. So if you're in PCI and a PCI compliant environment back in January 2019, they specifically called out open source in terms of being aware of what you're pulling in and making sure it's secure. But there's all kinds of regulation coming out more and more all the time. So kind of coming back to these Deming principles, one of them is to keep performance across the entire system. And it kind of key is not passing the defects downstream. So within that development cycle, you want to pick it up as soon as possible and fix it as soon as possible, because it's only going to take more time the later you find it and become more of a risk. So yeah, picking it up as soon as possible, and key to that is automation. So that kind of concludes the presentation. Are there any questions, or would anyone like me to go into more detail about anything I've spoken about?
Yeah, so if there are any questions from the audience, please use the Q&A box at the bottom of your screen. Okay, so thank you everyone. Thank you, Adam, for tuning in today. We hope to see you back on Monday. And on Monday, we have the Atlassian Community Berlin special at 6 o'clock. The topic is managing requirements and collaboration in Jira with BDD from Lauren Pry from Smart Bear. Have a wonderful weekend. Take care.
Thank you very much. Thank you. Bye.